Okay, today we are going to be exploring the concept of equivalent fractions. The word problem that we're going to use would be appropriate for 4th or 5th grade students, depending on their level. But the problem reads, Stacy has 12 cookies and she wants to give 2/3 of them to her friend. How many cookies is she giving to her friend? So the first way we're going to look at this problem is by using a set model, and we're going to use these color counters as manipulatives. And so we're going to let each of these colored counters represent one cookie. And our word problem tells us that Stacy has 12 cookies total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And 12 is our whole. 12 is our total. And so now that we know that 12 is our whole, we see that she gives 2/3 of her cookies away. So what we're trying to figure out is what is 2/3 of 12. And what this is called equivalent fractions. 2/3 is equal to what over 12. So when working with this problem, we're going to look at the denominator of 2/3 to tell us how many equal groups we're splitting our whole into. So the denominator of 2/3 is 3. And that tells us we're going to separate the total into 3 equal groups. So I'm just going to do that now. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So now that I separated the whole into 3 equal groups, we're going to look at the numerator of 2/3 to tell us how many groups we're interested in. And so the numerator is 2, so we're interested in 2 of these groups. This is 1/3 of 12, this is another 1/3 of 12, and this is another 1/3 of 12. So this all together is 3/3 of 12, since there are 12 counters, but we're only interested in 2/3, which is 2 of the 3 groups. So now to find out what 2/3 of 12 is, we're going to count the number of cookies in the 2 of the 3 groups. So 1, 2, 3, 4, 5, 6, 7, 8. So we see that 8 is 2/3 of 12. If we were to look at 1/3 of 12, we would count 1 of the 3 groups. If we were interested in 3/3 of 12, we would look at all 3 groups. And like I said, this is a set model that you would use with your students. Now, another way to look at this problem is by using an algorithm, and you would only want to introduce the algorithm after the students have a concrete understanding of fractions, as well as they have developed multiplication skills that they can rely on as well. So when comparing fractions and trying to find equivalent fractions, I'm just going to write 2/3 because that's how many she gives away. But we want to know what is 2/3 of 12. So we have 12, but we want to know what this number is. And they are equal, hence the name equivalent fractions. And so when you are finding equivalent fractions, whatever you do to the numerator, you have to do to the denominator, because you have to keep them balanced. So with your students, they would use their multiplication skills to figure out 3 times what equals 12. And they would know that 3 times 4 equals 12. So what they do to the bottom, they also have to do to the top. So 2 times 4 would equal 8. And just like we saw in our set model, 8 is 3/4 of 12. So, I'm sorry, 8 is 2/3 of 12. Some common misconceptions that students have when looking at equivalent fractions, when doing the algorithm, they only do the procedure to the bottom, they only do it to the denominator, or they only do it to the numerator. They don't understand the concept of keeping it balanced on the top as well as the bottom. And with looking at the set model, students aren't really used to finding fractions out of a set that is bigger than the denominator. So it would be easy for them to have the whole as 3. So what's 2/3 of 3? They're automatically recognizing that 2/3 of 3 is obviously 2. But students tend to have trouble when the whole is bigger than the denominator.